Assalamu alaikum and welcome to Salam Geographia. This is lesson 2 of atmospheric circulation model. It's just a continuation. We're going to keep the same objectives going. Last lesson we looked at trying to understand the global circulation system or the atmospheric circulation system. So there's a link below if you want to check that video out. We're not going to talk about it too much today, but we're going to try to make sense of why there's major sort of climate zones in the world, and we're going to look at 4 in particular. All right, so the first thing I want you to do is write down some questions about the different climate zones you can see here, just to get you prepared. And then you can pause the video, and when you're ready, you can unpause and do task 1, which is match the 4 different images to the different climate zones. So see if you can make out which image goes where. Okay, so how did you do? So as you can see in this image, you can see the subtropical zone is the kind of desert region. Then you've got polar zone, which is that very sort of cold kind of environment. And then you've got the tropical zone. So that's where there's a lot of those huge, like tropical rainforest kind of trees. And here you've got the temperate zone. So what you can do is also put an arrow pointing towards those areas. So this is temperate zone, and this is like where I'm located. So this is the UK, and this is the polar zone, and that picture's not necessarily taken from that area, but it's just like an example of what that area looks like. And then you have the tropical zone here, between the 2 tropics. Remember, lines of latitude are very significant here. And of course you've got the subtropical zone. How did you do? Okay, so let's just look at what climate is. So the climate is the average weather condition of a particular place or area, and that's the direct result of weather data, which is usually recorded over a long period of time, up to 30 years even. And we're going to have a look at one of the major factors that affect climate, which is latitude. And of course, it's important to understand the concept of insolation. And for insolation, we need the sun. So if you could draw this diagram in your notes, so draw a nice big sun and draw a model of the Earth as well, and then draw a dotted line around the Earth to represent the atmosphere around the Earth. Do that. Pause the video and draw that diagram first of all, and then we'll build on this diagram. So let's put in our sun rays. Here you can see the sun ray. The sun's energy is quite spread over sort of a greater surface than what it would be at the equator. So the equator is around about this region of the Earth. And then you have the same thing happening towards the southern hemisphere as well. So with the line of latitude, it's important to understand that the distance is quite significant from the equator. So it's important to understand that temperatures actually decrease as solar energy or insolation is less concentrated towards the pole. So the polar regions don't have as much concentration of sun as you would get in the equator. And there's also seasonal differences that you need to take into consideration in terms of the temperature, normally greater due to the effect of the tilt of the Earth. And it's normally, the Earth is on an axis, and it orbits the sun. So that's getting quite complex. But just for examples, like London, you tend to get a very huge difference. You can actually see the 4 different seasons. So the amount of sun's energy received in that particular location is more spread out. So you get kind of greater change between the summer and the winter compared to the other places. Like, so for example, with the equator, you get smaller change. So the energy received is always like quite high, and the length of day kind of remains more constant, and then you've got little change throughout the year. So that's the kind of background to this. So that this is all dependent on the tilt of the Earth as well, and where the sun is actually hitting which part of the Earth. So if we have a look here, we can see a the place, the spreading of those sun rays, and then here you can see a concentration at the equator, and then here in the kind of southern region you can see again spreading of the sun rays. So I've just labeled that for you, so add those labels to your diagram. So energy from the sun is spread out, and here it's concentrated, and then you can draw in your line of latitude, your equator line as well. So climate is the average weather condition observed through a recording of weather data periodically, sometimes over 30 years or so. Now let's look at this in relation to what we learned previously in the video. Remember, there's a link below if you want to watch the video for lesson 1, and that talks all about the atmospheric circulation model, or the global circulation system, in more detail. But as before, let's put the sun rays back in and just have a look at this model that we worked on last time. You've got the temperate low pressure belt, subtropical high pressure belt, north of the equatorial low pressure belt. And this is basically what's going on in those different regions. This sun that particular place gets is due to what's happening in those regions. So remember, here you have got areas that are the subtropical zone first. Well, okay, so here we've got a subtropical zone. So as you can see, it's a high pressure belt. So it's just that area where you get lots and lots of deserts. Air is cool and dry and descending, remember, and it's kind of that area between the Ferrel and Hadley cell. So what's happening here is that around about 30 degrees north and 30 degrees south of the equator, there's high pressure, and that's a result of the sinking dry air, because the Hadley cell and the Ferrel cell are meeting each other, and this creates a belt of like desert regions. And you know those areas like the Sahara in North Africa. This is why those areas are so sort of dry. Daytime temperatures can go like beyond 40 degrees C, whilst at night, due to the lack of cold cover, temperatures can fall to below freezing. So that's like pretty major extreme weather in that particular area. So as you can see in this model, you can see exactly where it fits in that particular climate zone. Let's have a look at the next climate zone. So the next climate zone we're going to look at is the tropical zone. This is a belt of very low pressure. So you've got lots and lots of heavy rain and thunderstorms. And that, remember, is a result of that rising air that you get in the Hadley cell. Lots and lots of moisture in the air here. Those big, massive clouds. Lots going on here. Places such as North Brazil and South America, and places like Malaysia and Indonesia have these beautiful rainforests. So that Southeast Asian area as well experience this kind of tropical climate. So you've got lots of vegetation forming. So remember, you can make your synoptic links here as well with the ecosystem lessons. Out here are your polar regions. Now the polar regions are very interesting. They're at the highest latitude, so you've got lots of cold air from the polar sinking, and you've got a production of very, very high pressure, and this is characterized by dry, icy winds, and it's caused by the spin of the earth. Remember, the earth is on an axis and it's like spinning, and in some places in Antarctica they say that the average annual wind speed is almost 80 miles per hour, and that's pretty fast. You've got to think about like the motorway. You know, I think you can't go above 70 miles per hour, so this is like 80 miles per hour, so faster than, you know, going at top speed on motorways. So it's very important that we understand what's going on in those different zones. And of course, the temperate zone. Okay, so this is, so if you're UK based, this is basically what the climate is like in a place like the UK. So the temperate zone in the mid latitudes, we would say like the 50 to 60 degrees north kind of area or south of the equator. You get two types of air meeting. One's going to be warm from the Ferrel cell, and one's going to be cold from the polar cell. So you've got low pressure being created here, and that's from the rising of this warm subtropical wind over the cold polar winds that at that particular front. And this air rises and cools, and it condenses as well, and it forms those like fluffy clouds. So they kind of cause a lot of rainfall in those regions, so that whenever they like make fun of UK being like a very, very kind of rainy place, that's why. Basically it's because we're in that interesting kind of zone where we've got so much happening in the Ferrel zone. And then you can kind of relate that back to your lessons that you did in school, maybe on what's happening in those high and low pressure areas. So often we get, you know, stormy, cloudy weather because the hot air rises, and then that creates the stormy kind of weather. And then we also have that kind of dropping of the air with the high pressure area, where we get that clear, calm weather as well. So we live, like if you live in the UK, you have a very kind of mild kind of day-to-day weather. And remember, climate is different to weather. Climate is like an average of the weather over a long period of time. So that said, I want you to just try to think back to that original atmospheric circulation model and see if we can make sense of those different places. Again, you can pause the video and keep reminding yourself of this model and see if you can have a go. If you didn't do so well last time, maybe you can pause the video and see how fast you can do this this time. So you should be able to now draw a circle and split your Earth up into two halves, and then place the different lines of latitude and be able to name them as well. Okay, and you can add the names to your cells. And remember, if you can remember this, then this is really good framing for all of the other topics that you're going to do in physical geography, because it's really, really important that you get to grips with this model, because it's a model that kind of helps you understand a lot of the different topics. So especially if you're doing Geography B, OCR, you will understand the topic, our natural world in more detail. So like the physical side of geography. So it will help you with the changing climate topic. It will help you with distinctive landscapes. It will help you with sustaining ecosystems, and of course, global hazards as well. So it's really important to get this model clear in your head. So you just pause the video and test yourself again, and then unpause it when you're ready. So the idea of this activity is to what I'd like you to do is write a summary of what happens in each climate zone and make links to the atmospheric circulation model. Spend about 2 minutes on each climate zone and get into exam zone or the exam mode. So it's like what I'm trying to say here is that you need to be able to write fairly quickly. And in order to prepare for an exam, it's good for you to know what to write. Okay, so once it's in your brain, you write faster. So once you've written it down, you'll be able to memorize it. And you have to keep practicing this and see how much you can write in 2 minutes, because often when you're given a one mark question or 2 mark questions, you are expected to spend about a minute per mark on a question. So it's really, really important that you learn to write as fast as you can. You need to also talk to your teachers if you have trouble writing fast. Maybe your teachers can arrange for you to have some sort of typing facility so that you can be helped in that way. Remember, you can actually talk about this in more detail if there's some sort of learning need that you might have. It's always good to communicate that very early on. If you find that it's really, really difficult to actually write fast or think and write as well at the same time, then these are skills that you need to either develop or talk to your teacher and say, look, I'm having trouble. And it could be something that you could have help with, if that makes sense. Once you've done that, you've got your 4 different climate zones, and you've made those links. Create a slide with all of this information and download some pictures for each zone. You can have a climate zone map too, just to kind of make your notes look interesting. You can make a PowerPoint slide of your own. Remember, this just helps you sort of revise, and you can kind of present it to your other fellow students as well. So what synoptic links can be made as well with other subjects? So remember, I talked about how this understanding of your circulation, atmospheric circulation model can help with all the other physical geography topics that you're expected to do as well at GCSE. So it's really important you can make those links here. So thank you very much for tuning in. Coming up next will be extreme weather. So we're going to have a look at extreme weather next and try to make sense of all of that. So thank you so much for watching this video. I really hope it was useful. Remember, these videos are designed for you, the students and teachers, just so that you can get your head around certain diagrams and concepts. I hope these lessons are useful for you in some way, whether you're revising or whether you're learning something and trying to make sense of something that you've learned in school. Thank you very much for watching.